And welcome to the hackathon closing. Hope you had a good week, and we have thanks to all of you for joining. I see we have a good list of presentations lined up. I want to wait just a couple minutes for those people who are still joining. While we are waiting for people to join, I want to just cover a couple things that I'll cover again at the end. But I figured, some of you may not be able to stay for the whole time, although I hope you can. So let me just briefly share this. First of all, there is a survey for the hackathon. The link has been added to the wiki. So if you go to the hackathon wiki, you'll find it. But I also put it here in the slides, and I've uploaded these to GitHub, so you can grab them from there as well. Then the other thing I wanted to mention is a draft. And I actually first shared this and had it discussed at the last IETF meeting, and there's been some updates to it now, and it'll be discussed again in the SHMU working group. And it's basically covering the hackathon, how it works, kind of from a process perspective, just to capture, this is how we run the hackathon and why we do things the way we do. And also part of the reason why it was created was, and the whole SHMU working group has to do with, dealing with meeting online as we are now, both for the IETF meeting, for the hackathon. And so the draft isn't specific to that. It really covers the hackathon overall, but also aspects that are either new or different when you're running it online. So would appreciate if folks here, while everything's still very fresh in your mind, if you could take a look at that. It's not very long. It's maybe 10 pages or something like that, with a lot of kind of boilerplate stuff. So it's a pretty quick read. And if you have any thoughts, I'd love to hear them on the list. A pull request, it is on GitHub. There's the link. You'll find that on the data tracker. And with that, I think I will go back to the start and we will get started here. Okay, so just a reminder, some people maybe didn't attend the beginning, but I think it's always good to attend the kickoff. I think it's always good to just recap why we're here, and that's really for the hackathon, the whole idea is to advance the pace and relevance of IETF standards, to really bring together that spirit and of collaboration that we get with the open source community, and work on code that's related to the things we either have standardized or in the process of standardizing, or have some ideas about, anything really related to IETF standards. And the goals of that are both to, make the standards better, right? Because we're getting feedback from actually having coded things, but also just to attract developers and new people into IETF, and to take some of the stuff that, to progress really from just the specification, which is great, to if you actually have some code that can help you get started with implementing or adding support for the draft, or with testing things about, a protocol, that's all great too. So those are the big drivers for the hackathon. I want to remind everyone of the note well. We talked about this in the opening, that the code you work on is governed by whatever the license is of that code. Hopefully it's open source code. That makes it easier for everyone to collaborate and share. But anyways, you have to look at the license and the rules and restrictions there regarding the code. But when it comes to the presentations that we'll all be enjoying during the closing, those are your normal IETF contributions and fall under the note well. Okay, the agenda. So we have 2 hours. I don't think we'll need the full 2 hours, but based on the number of presentations, my guess is we'll take a bit more than 1 hour. So 1 hour plus. We'll definitely finish before the end of the 2 hours, and we'll have some time for discussion at the end. And the way it's going to work is we're basically going to run through the list of projects in the results presentation schedule. And this is on the wiki if you want to take a look at it. I might have a slightly dated version here, but it's pretty close. I just grabbed this maybe an hour ago. And the plan is to just run through in order. We'll start at the top, we'll work through them. If anyone's not able to present during their slot, we'll try to go back again at the end. Or if someone knows in advance that they have a timing issue and need to present in a different order, we can do that too. But this is just to make it a little bit easier for everyone to know when to expect to hear something or when to talk. And the idea is that each of you can drive your own presentation. So when your slot's coming up, if you can put yourself in the queue and then share your screen, share your audio, share your video, that would be fantastic. And if you run into any problems with that, I'm here to help you along. Barry's here, and Alessandro, I see, is here from Miteco. So we should have all our support that we need to run this smoothly. Just a quick reminder here, the presentations, as we mentioned before, the idea is these should be quick presentations, short presentations, just covering some highlights, kind of up-leveled to present what's relevant to the IETF community, even to folks who aren't deeply involved in the technology you're working on. The idea that this is just to give people an introduction to what you did and share some of the highlights. And then people can always reach out to you for those more detailed discussions. But we like to focus on not only like what worked, but just what did we learn in general, and especially feedback that you're going to bring into your working group that may help with the work that the working group's doing on various drafts and standards. And then also it's nice to see when you worked with some open source code or with people from an open source community or from another SDO. Because what we found is that code is actually a great way to collaborate across the typical IETF sort of boundaries of a draft and a small community. It's a way of expanding the scope there, because we know there's a lot of great code all over the place that isn't just relevant to the IETF community, it's relevant to other communities as well. So this is a great way to engage with them, and we like to just be aware that that's happening. Okay, all of the projects should be uploaded to this repo in the IETF GitHub. If you haven't uploaded yet, that's okay. You can present just the version that you have on your laptop. That's fine. But just afterwards, please go ahead and make sure it's been uploaded. And if you've already uploaded it, that's ideal, because that way people can follow along with your presentation if they want to. So this repo will remain open after the hackathon closing is done. And so, if you find things, if you continue to work on your code the next few days, whatever, that's great. You can update your presentation to capture that. Okay, so with that, we're going to get started on the presentations. This again is a snapshot. I'm going to pull up the actual list and go off of that, what's on the wiki, but it should be quite close. And any questions before we begin? Okay, so why don't we get started then? Application aware GSR v6 networking.
Hello.
Hello. Yeah,
Hear
hello.
me?
Yep, I can hear you. And let me stop sharing. So you should be able to share your screen. We see your video. Don't see your screen yet. Okay, great.
How to share?
You should, I just granted you that, so you should see something, a pop-up asking you
Okay,
what
can
you
you
actually
see
want to share.
my? Okay, can you see my screen?
Yep, looks good.
Okay, thanks, Charles. Hello, everyone. My name is Jianwei Mao. I'm glad to introduce our project for you. It is application-aware GSRv6 networking. Our plan is to develop GSRv6 on the Linux kernel and combine GSRv6 with APN6. Here are some related IETF drafts for your reference, and we have built up some open communities for you. Now let's talk about GSRv6 first. As we know, SRv6 is the latest routing technology nowadays. GSRv6 can resolve a critical problem of SRv6. The transmission overhead of SRv6 is too high. For example, if you want to use a strict TE tunnel with 10 seeds, the seeds will occupy 160 bytes in your packets. That is not accepted in interactive control and IoT scenarios, which packet length is under 128 bytes. So how about GSRv6? The key point is GSRv6 can reduce 75% transmission overhead. That means the size of seed list is cut down. Moreover, GSRv6 can reuse the locators of SRv6. That means if you want to deploy GSRv6, you don't need to apply for new IPv6 address blocks and advertise new IPv6 routes into your network. So you can deploy GSRv6 incrementally and on your demand. It is full compatible with SRv6. By the way, there are about 12 vendors. Their devices have passed interoperability test of GSRv6. Next, let's have a look at APN6. APN6 allows devices to identify application-related information and use IPv6 extension headers to convey the information along the packet to traverse the network. The information contains APP ID, SLA level, bandwidth, delay requirements, and so on. So network can quickly adapt to specific SLA requirements of different applications. Okay, based on GSRv6 and APN6, we present application-aware GSRv6 networking. It combines their advantages to enable application-aware fine-grained strict TE with lower transmission overhead. In this hackathon, we implement a demo for it based on Linux kernel and Huawei router. In detail, for GSRv6, we build a kernel module to identify APN6 information and select the most suitable GSRv6 TE tunnel for specific application flows. After that, it can encapsulate GSRv6 routing header to packets. For APN6, we develop some functions to encapsulate APN6 options with application-specific information in IPv6 hop-by-hop options header. We set up a 3-layer topology for this demo, and we tested the performance between SRv6 and GSRv6. In this demo, we programmed 3 TE paths for 3 kinds of applications. All of the paths are with above 10 hops. That means there are above 10 seeds in the seed list. The 3 applications are, first, file downloading. with security checking in a service function chain. Second, interactive control, which is using leaf and short messages. Third, high-definition video on demand. For the result of performance test, we can see, first, forwarding rate of GSRv6 is 55% higher than SRv6. Second, for the interactive control scenario, which packets contain only about 128 bytes in the payload, the transmission overhead is reduced by 50%. Third, we can see the bandwidth utilization of GSRv6 is 10% higher than SRv6. Finally, for this hackathon activity, we can bring some feedback to working group. The most important is GSRv6 can improve the utilization and value of bandwidth significantly and guarantee SLA better for applications. By the way, we have made some future plans. We plan to make some POC tests in wider area networks, such as CINI in China. And you are welcome to join us to improve this demo together. Okay, here are my teammates. If you have interest for our project, please send us an email. Thanks for your listening, and thanks to my teammates. Thank you.
Okay, well, great presentation. Yeah, thanks for getting us off to a good start. Does anyone have any questions before we move on to the next presentation? Okay, well, great. Thank you very much.
And thank you very much.
We'll move on to network telemetry. Thomas.
Yeah, can you see my screen?
Yes, looks good.
Perfect, excellent. So yeah, I'm representing BMP and Young Push from the Grow and NetConf working group. So here our plan, our hackathon plan is we are on the BMP side. We were focusing on performance. So basically, we are interested to see.
Just one, if I could interrupt you quickly. At least on my side, I see pop up on top of the title of the screen.
I see.
About sharing. Maybe just minimize that or move it. Yeah, that'd be great. Thanks.
Sure. I think let's put it somewhere else. Yeah. Okay. Great. Thanks a lot. So on the BMP side, our focus is basically we want to understand what is the impact of BMP onto the BGP process, especially if adjacency RIP in, out with local RIP and path marking is enabled onto CPU and memory consumption. On the other hand, one of the interesting part of BMP is that you can get an exact copy of the BGP RIP state, and we want to understand here if when BGP congestion is here, if under all circumstances we can rely that there is no loss present. And on the other hand, when BMP is enabled, we want to also understand what kind of impact it has on the BGP route propagation. So that's about the BMP part. So on Yang Push, there basically we're working on an open source implementation of UDP notif and distributed notif. So we have a data collection implementation and also a mockup publisher, and we were integrating it into the PMA-CCT open source network data collection. In this hackathon, we were also focusing here on testing the efficiency and the throughput on UDP Notif. The main focus on UDP Notif is that basically Yang push can be implemented directly on line cards on the network processors. So here, important for us is that we can maximize efficiency and throughput. This is the software we are used in this hackathon. This the network. So here on the very left-hand side, this is basically where we are ingesting the BGP VPNv4 unicast routes. These two routers are basically route reflectors, and on the very right-hand side, this is the provider edge routers. And these little boxes in here show basically the BMP coverage, so what RIP we are exposing towards the data collection, which is in here. So on the lab environment side, I mean, this is not the first time we were participating the IETF hackathon. So we are from each hackathon steadily improving. So in this time, we were focusing on test automatization. So we are basically generating sequenced BGP VPNv4 unicast routes. We are basically, before we are starting test, initializing the BMP state, collecting then the BMP metrics from the network to see, to detect any loss or delay. And with Yang push, we are measuring the impact on CPU, on memory, onto the BGP process. So here, this time, focus was on BMP route monitoring, where we want to, which we want to use to detect any loss of metrics and also delay into the BGP propagation. Now, we, as a next step, where we want to improve in this testbed, we use this time, we were focusing on Huawei VRP. We have also IS6R and Juniper Junos in the testbed present, but because of the time restriction, we were not able to use it. So in the next IETF hackathon, the next step is also to interoperability tests among vendors. And since timestamps are important on detecting delay, here we saw some improvements we like to add in the next testbed. On the Yang push side, we were focusing on the implementation on the UDP Notif draft. Here we have an implementation now open sourced in C. It's supporting the segmentation option, and it's integrated into PMACCT. It will be soon after the weekend available on GitHub below the GitHub link. And we are working now since several months towards this goal. So this is basically the first UDP Notif message which we captured during the IETF hackathon in a Kafka JSON message. So this was like a child's birth moment for us that we finally reached this goal. From a throughput point of view in UDP Notif, to be honest, this was like really a big thing for us because one of our big aim was to bring performance and scale into Yang push. So in this test setup, we had we were focusing on one core, and we want to understand how many, basically how many megabits with 500,000 messages we can bring through. And depending on the message size, we were able to get a throughput between 400 megabits and 11.5 gigabits per second. And to be honest, compared to what we have today in our networks with gRPC, this is a huge difference, and I think this is a game changer. Now back on BMP. On our test cases, we were focusing on route reflectors and provider edge routers, where adjacency RIP in pre-policy, local RIP, and adjacency RIP out post-policy was enabled with path marking support. And one of the key findings was under stress conditions, basically, that the CPU increased after the BGP was converged. So, and for the memory part, there was a slight overall increase throughout the test cases, and I will show some graphs afterwards. And what was pretty impressive and was also a big surprise is even under stress condition, the BMP route monitoring was always be very consistent. So at the end of the test cases, the state mirrored with BMP and the state on the routers were always matching. So we did not lose any metrics. Regarding the BGP propagation delay, when BMP is enabled and not enabled, here we found out that basically the test bed was not accurate enough. The delay is actually in a very low sub-second area. And in order to draw a final conclusion, we need to improve our test bed. Here, just an example on BMP
Yeah, Thomas, just to let you know, we are over time. So if you could kind of wrap up, that'd be great. And then we can look at the rest of this.
Then this is just basically the final results on BMP, wherever they are enabled or disabled. And here, basically, you see basically if BMP is flapping or not, there is no impact on it. So the good thing about this hackathon was it was well prepared. We had a good test automation. We were, thanks to Slack and Teams, very well connected. Same again as last time. We were missing the beers and cocktails, and thank you for all our colleagues who participated in this hackathon.
And thanks for the presentation. Hopefully we're getting closer to the cocktails and beers, if not the next hackathon soon. I did have one question on the timestamps. I didn't quite catch, is that a change that you would also need in the draft, or is that just your test bed to test what's going on with the draft?
No, that's basically the draft supports basically timestamps in seconds and also in milliseconds, but in the vendor implementation, it was not it was not precise enough to measure the delay. So we need to improve basically the vendor implementation.
Okay. So perhaps there maybe some of that could feed back into the draft, though, as a recommendation of a reason why implementations, even if you could do just the seconds, you know, like why to use one, implement something rather than, you know, at a deeper level. I don't know if some guidance could go back into the draft, because it obviously wasn't evident that those timestamps would be needed at that granularity. So it seems like something that.
This was one of the key findings that in order to measure such a propagation delay, such timestamp in such fine granularities does make a difference.
Great. Anyone else with any questions? Okay. Thanks, Thomas.
Thanks a lot.
Are you here? Yang model for network tester. Oh. I don't see Vladimir. He had warned me he may be a little bit late. Okay, let's go on to the next one then, and we'll come back to Vladimir at the end. Tom, if you're here, NS3 models. Let's see. Do I see Tom? Okay. Actually, Vladimir, I can see you're here. Are you ready to present, or would you rather we come back to you? All right. Well, then we will go on to Sebastian.
Hi, can you hear me?
Yes. And you should be able to share your screen now.
Sure. I'm just fiddling with the screen share.
Okay.
Trying to get the right window. Excuse me. There's one. Okay. Are you seeing the slide?
Yes.
Fantastic. Okay. Thank you very much. This is my first IETF hackathon. It might be a little bit different from some of the other projects. Big Bang is a software toolkit that's for studying collaborative communities in general, and especially standard setting groups. So what it does is it ingests email, Git repositories, it ingests stuff from the IETF data tracker. As of this hackathon, it ingests listserv data, which some other standard settings groups use as a communications tool. And then it combines those with data science tools from the scientific Python stack for entity resolution, social network analysis, natural language processing, time series analysis. We're expecting to start working with a group that does information extraction soon. And it's a little bit different from ARCO's RFC stats, which we love and are inspired by, because it brings in a wider range of data sets and supports different kind of research questions. So the Big Bang kind of research community has both social scientists that are interested in standardization, collaboration, and the IETF in particular, and also computer scientists developing new kind of data science methods for using this kind of data. So it's got a number of different groups contributing. Article 19 is an NGO. There's several university researchers that are involved. Not on this list is some participation that's very, very appreciated from the University of Glasgow. We're building a Python interface to the data tracker. And for this sprint, we saw a number of new participants going, including a new user and a new software contributor who's made a lot of very great improvements. We did a lot of just sort of basic maintenance and updating of sort of the installation procedure to keep up with changing underlying dependencies. We produced an instructional video about installation basic usage, did some debugging, and built in this listserv sort of scraping tool, which we want to apply later to other organizations like 3GPP. We also did some more substantive sort of analysis or even science with the data. One project that Nick Doty did was about attendance analysis, and there was some other work about looking at organizational involvement via email data. So this is from Nick Doty. This is a plot of IETF meeting attendance by country over time. And what he was interested in particular was the last 3 meetings had been remote. you can see they've got sort of the red x-axis tag. And he was pleased to see that there was increased attendance relative to prior meetings because the meeting was remote, though not quite as high as when at sort of the peak of IETF attendance, which was I guess around 2004 or so. But the other thing that he noticed was that you can see, say, in let's see, meeting 76 or 94, where there's a higher percentage of people attending from Japan. That's because of the location of the meeting. So we can see swings in the nationality of attendance based on the location of the meetings. The remote meetings seem to lose that locality effect, which I suppose is expected, but is something to keep in mind, I suppose, going forward. The other thing we really dug into in terms of data analysis was some of the research groups that are involved in the project are very interested in which organizations or which are influential in which working groups. And while there's author stats work that definitely supports this sort of stuff, it doesn't generalize to other standards groups that don't have as wonderful a tool as Data Tracker. So we're trying to explore this using email domains for participation in mailing lists. So theoretically, you could use the email domains, so basically everything after the @ sign. But there are some challenges. There's a lot of people, especially in the IETF community, that have personal email domains. And there's also generic email hosts like Gmail or GMX, which encompass several different individuals. And we're trying to work out data cleaning methods to make this a little more useful. We're experimenting with a kind of entropy threshold of email on the distribution of email addresses per domain. And we found this quite effective at filtering out personal email domains. We're still trying to figure out what to do about these generic email hosting issues. But so far, we've been pretty good at successfully isolating when an email domain is coming from a corporation or organization, as opposed to representing like an individual, which is what we're kind of trying to get at. So for the future, we plan to release some improved documentation, hopefully make a containerized environment so that people could interact with the data through an interactive notebook, as opposed to having to sort of download and install the whole thing. We've got some plans to refactor the core code for better encapsulation. And we want to develop a kind of standardized process for looking at organizational involvement that works not only on IETF data, but also through GPP, W3C, ICANN, etc. And we're looking to work with another group in the future that specializes in knowledge graph construction, and we're very excited for that. So you can find out more about the project on our GitHub page, and there's a mailing list there, which you're happy to join in and check out and join the discussion. And that is all. Thank you.
Great. Well, thank you very much. That's some neat information. I look forward to seeing is that more analysis comes out of that. Are there plans for like sharing any of the data that you're generating in I don't know, in the IETF plenary or some other format? It's cool to the hackathon community from the tooling perspective, but a lot of people would be interested in the results you glean. So
that's a great point. As I said, this is my first IETF attendance, and I've been working on the Big Bang software for some time. There's others in the Big Bang community that are more into IETF, but I'll bring that up with them. I think we'd love to present this at the plenary.
Cool. All right. Well, thank you. All right, we'll go on to our next presentation. I see Yari, you're here.
I'm here, but I was wondering if I could ask still a question on the previous one.
Oh, sorry.
Yeah, so it's just really great stuff, very interesting, and indeed we should hear it in a more general setting in the IETF plenary or something. I did have one comment on this generic email stuff, and there are ways to deal with that. One of the things that worked for author stats was that you could by hand basically list the most important generic email domains and by hand list the most interesting companies or most companies that many people work for. And from that, you can actually override the email domain information. So you could actually analyze a little bit of who does what, because people sign their company names in the documents with the company, or provide the company name in the documents. So that's one way, perhaps, that you could consider.
That is awesome. And thank you for your question. Of course, we're paying attention to your work. If there's any way we could reach out to you and get your list of hand-edited email addresses and domains, that would be incredibly valuable. But I think that's something we're thinking about doing down the line. It's just a lot of work.
Yes, you could. Let's talk offline.
Bye-bye.
Okay. And Jari is also our next presenter, so.
Yeah, so this team worked on quick measurements, and quick, of course, is an encrypted transport protocol, which means that measuring it is much harder than it was for, say, TCP, where you could just look at the ACKs and so forth. The quick standard does have some features for enabling some specific or explicit measurements. For instance, the spin bit allows some things to be measured. And we've built some software in earlier times, 2 or 3 years ago, already started work on something called spin dump, for instance, that can look at quick flows and understand what's going on.
At least I don't see your...
Okay, should I, let's see. Do you really want to share your screen? Yes, I really want to share my screen. Do you see it now? Do you see my screen?
It shows Jari Arko's screen, but it says it's all black. I don't know if anyone else sees more than that. No, it looks like it's
a black screen. Same here.
Yeah. Charles, could you perhaps share instead, just about the problem?
Yeah, I think so. Let me...
Okay.
Yeah, let me pull up your presentation. I'll download it.
Hold on, maybe I still need to do, no. Yeah. No, it doesn't allow me to do it.
Okay.
Yeah. Just go on the,
yeah, try to share it.
Go on the first one. Oh, I'm seeing a black screen now. Yeah, perfect. Thank you. So we built a software called SpinDump to help analyze some of these encrypted traffic flows to the extent that we can. And we've been working on that and expanding that in various directions in several hackathons, actually, over the last year and a half or so. This time it was these people from Telecom Italia, Huawei, University of Hasselt, and Ericsson who participated there. If you go to the next slide. And so we worked basically on 4 things this week. The first one is like new research on different types of measurements that we could do with encrypted protocols. And there's a draft, and there's an implementation of the draft in SpinDump integrated into the software. You can go take a look at the draft. I won't go into details of that today to save some time. We've also worked on Android tooling. So the idea is that users could run this measurement tool on their phones and provide some measurement data to a central point instead of having the network do these measurements. And one thing that we actually were surprised by a little bit in this effort was that it's quite possible to measure quick flows, at least when there is the spin bit is being used, but it's quite difficult to use or to observe TCP for the reasons that some of these platforms hide some of the traffic from us on the phone platforms and so forth, and it's not possible to see all packets. Even with this like packet capture interfaces, or alternatively, one would need more permissions to see everything. But so it's been kind of an interesting side effect of this encrypted protocols that they actually go through everything on the endpoints and in the network, and you can see what you can see. Obviously, you can't measure everything, but you can see the things that were designed to be seen everywhere. We also do quite a bit of monthly maintenance of the software, so we need to update it usually with new versions of QUIC. Now, fortunately, the QUIC protocol is being released as RFC, so the version has been set as 1, and that's it for the moment at least. But we did integrate a few PRs and fixed a number of issues, added some features, did some interop testing. And one of those features that we added is QLog, and QLog is like this logging format that is supported by many endpoint implementations of QUIC. It's mostly used initially, at least, for debugging purposes. There's a couple of drafts, you can go read them. We chose to add QLog as a possible output format from Spindump. And the idea is basically that you would get information from several directions. You would get it from the host implementations. You would get it from network tools such as Spindump. You would get it from the server implementations. And then you can put all of this information together and then use tooling built for QLog to look at like what is the situation from different viewpoints. And if you go one step forward, it's the last slide. So this kind of sounds maybe complicated, but it's quite simple. QLog is JSON essentially, and it consists of basically an array of events, timed events, and then there's information about the protocols and so forth. And what we've been able to add there is measurement events. And there's various kinds of measurements that Spindump does. What is shown on the screen is just one example. But that's basically it, and looks interesting. I think we are going to have to stop the coding for a moment and think about some of the drafts going forward. The drafts are being discussed, I think, TSV WG in the coming week by Robin. But since they started from this logging, debugging perspective and not from the measurement perspective, then building those measurement capabilities into the formats will probably take a little bit of effort. So we sort of identified opportunities for improving the drafts or writing new ones perhaps. So that's it.
Great, thank you. One question I had, so you can identify that the flows are quick. Within the quick flow, can you identify kind of subflows within it, like, or is it just that this traffic is quick? Or
you can identify a particular quick connection or a pair of connections going between two parties, but like what subflows or streams are inside one quick flow, you cannot see, and that's by design, of course. You can't see what encrypted traffic is being fetched.
Okay, got it. Thanks. Any other questions? Okay, great. Well, thanks, Gerard.
Thank you.
Okay, let's go to our next presentation. I need to get back to my list here. Oh, it's me. Okay. Karsten unfortunately couldn't be here as no one from the ASDF Wishy team was able to be free at this particular time slot. So I just have a very quick update from them. Let me pull that up and I'll share it with all of you. Okay. So on behalf of the ASDF Wishy team, just wanted to give you a brief update. So this project, it's a joint project between the ASDF group and the chairs from that group running it along with the T2TRG group. And that's really where Wishy is being discussed. And so the goal for them was to validate SDF 1.1. I believe at the last hackathon it was 1.0 they were working with. The semantic proxying, trying mapping files, etc. A link to their GitHub code and wiki can get more details. A rather exploratory hackathon is how Karsten phrased it. But two pieces of code did come out of that will aid with model transformation. So the good news is the results of the hackathon are already expected and planned to be discussed in more detail in the actual working group and research group session. So I have them listed. They're both on Thursday. So for those of you who are interested in hearing more, that'll be a great opportunity to engage with those groups and discussions around the hackathon and what they accomplished and learned. And with that, I think we will go back to our next one, which, Paul, we have a couple presentations from you. And great, I see you're here. Let me
Hello, Charles. This is Paul. Can you hear me?
Yes, I can.
Okay, great.
You should be able to share your screen now.
Okay, sure. Okay.
Okay, we can see it. We're on your wrap-up slide, though. And now it just switched to presentation mode, which may not be the best format.
Okay.
Yeah,
so
that's better.
It is great, right? Okay.
Yep, that's good. And then just one more thing. There is a little pop-up near the bottom, which maybe you can just move that. It's
okay. Oh, okay. What's going? Okay. Okay. Can you? Okay, it's good, right?
That looks great.
Okay. So hello. This is Jehom Parjang from Songyuan University. I will share our hackathon project I2NSF this time. So this is our poster. So this time we want to implement I2NSF monitoring data model, and also we want to show the proof of concept of security management automation new draft. So especially this draft propose application interface for delivering feedback information from I2NSF analyzer to security controller. So basically, this is typical I2NSF framework. So this time, denial of service attacker generate the TCP flood traffic to web filter network security function A, and then analyzer collect the data from NSF A, and then using a machine learning ML, it detect NSF A is affected by DOS attacker, and then using application interface, analyze, deliver the feedback information, such as the DOS attack from somebody else. And then security controller translate that feedback information into new security policy and then deliver over NSF facing interface, and then new security policy is enforced by NSF-A, and then it can drop TCP sync messages. So this is monitoring data such as CPU, memory, other resources are monitored, and also using the observation of DDoS attack, and then IETF analyzer can detect. So this is the information the attacker source, and this is the frequency of TCP flood. So basically, what we got done, so we implemented the monitoring interface and then analyze the DOS attack. Also, we deliver the feedback information over application interface, and then security controller translate high-level security policy into low-level security policy, and then deliver that new security policy over NSF face interface, and then NSF using firewall, and then it can drop the TCP flood. So what we learned this time, so we implemented the monitoring interface, and also we recognize monitoring packet flows in NSF to detect the DOS or DDoS attack. We needed to flow-based traffic monitoring is required. So this time we showed the feasibility of application interface. This is newly proposed by IETF working group for security management automation. So next step, we have 5 items. We want to extend monitoring young data model, monitor packet flows, and also we want to use S-Flow along with the IETF monitoring interface to observe net traffic monitoring. Also, we want to improve IETF analyzer in terms of machine learning, and also we want to update automatically sort function chaining of NSF corresponding to the security policy. And also we want to enhance security policy translator for security management automation. This is our IETF open source project at GitHub. So this is a new repository for this time. So this is my team. Okay, so this is a collaboration work with the Sungsil University from Professor Yang Kim's lab, and from Atri, Dr. Jung Soo Park and Mr. Injo Choi, and we have students. So Patrick, he is a main player this hackathon, and Dr. Jin Young Kim and Jung Hyun Kim and Yosop An are my student and my PhD. And also I have Moses Guo, he's an intern from Liberty University in the United States, and also I have visitor student Kyung-Sik Kim from Gyeongbuk National University. So we work together with IP-Wave and the BMW working group teams. So those are our sponsors. Thank you for listening your my presentation. Thank you. Any questions or comment?
Yeah, I did have one question on the Yang model that you mentioned for the monitoring. Is that is that an IETF? Like, is it a standard Yang model that's being developed?
Oh, this one?
Oh, there it was. Okay.
Okay.
So yeah. And it's in the I2NSF working group.
Yeah, this one is the I2NSF working group. So recently, Young Doctor approved this Young model is ready to be working with RASCORE. So currently, this draft under working with RASCORE. Okay.
Okay. Thank you.
Okay, great. So, okay. Charles, can I move to next presentation?
Yeah, I think so. Unless, did anyone else have any other questions? Otherwise, yeah, we'll move to the next one. I don't see anyone in the queue, so go ahead.
Okay, great. Okay, this is IP wave basic protocols project. My name is Jaeun Jung. I'm from SKKU, Sungkyunkwan University. So this is a poster. Basically, previously we had 3 hackathons. The first one is we demonstrated the IP version 6 packet transmission over OCB Wi-Fi modules, and also the 108 case we implemented simulation of a context-aware navigation protocol. And last hackathon 109, we started to implement context-aware navigator protocol. So this time we used the R1 I1 robotics robot. It can be controlled manually or autopilot mode. So this time we manually controlled. Next time we try to autopilot mode. So it supports the Linux kernel in terms of real-time Linux. So it also likely to be support IP wave stack, but still we need to implement IP version 6 stack. So this hackathon is based on context-aware navigator draft. So basically, context-aware navigation protocol means this is a highway. Vehicle 2 hit some obstacle in a highway, and then it delivers some emergency context message to neighbors, and then this guy and these guys received this one, and then already they are exchanged using correlation context message having position, direction, speed, acceleration, behavior of drivers. This one can be play or lot of cluster header, and it can adjust the maneuvers of neighbor vehicles to avoid accident. Those are our previous conference and internet draft. So basically, our context-aware navigation protocol based on neighbor discovery message option is called the Vehicle Mobility Information option, VMI. So this is ND option. So we support the correlation context message and the emergency context message. So basically, we implemented and tested using robot R1, A1 robotics. So they exchange message CCM and ECM. But this time we implemented the UDP instead of ICMP version 6. This hackathon we tried to implement ICMP version 6. So we tried to extend the Ubuntu Linux kernel for ND. It turns out there is some high complexity. So we just designed how to extend the neighbor table that is a neighbor cache, and also it has an entry for neighbor using neighbor structure. So we try to take advantage of current implementation, and we want to extend the ND option. So still ongoing work. Hopefully next hackathon we try to finish. So next step, we will continue developing and debugging a new option called the Vehicle Mobility Information option in Linux kernel. And also we also will support context-aware navigation protocol based on this new option. And then we'll test this IP version 6 neighbor discovery, and also we will support the autopilot mode of robot cars, such as CMP, context-aware navigation protocol message exchange, such as there is some accident or obstacle ahead of it. Vehicles can exchange the message, and they can avoid that obstacle or the collision with each other. So this is IP Wave open source project at GitHub. This also collaboration work with the Sungseo University Professor Young Kim and my PhD student BNMA and Chris and Don. They are my PhD student, and Kyungjae Sun from Sungseo University and Jino Park Gyeongbuk National University. In the same way, we work together with the I2NSF and the PM working group teams. Those are sponsored, especially TTA provided R1 A1 robotics robot. Thank you for your attention, and thank you. Any questions or comment? Okay, Charles, that is my presentation. Any question or comment?
No, thanks. That was great, and good to see the team coming back and
okay. Yeah, my student gather together here. Okay, thank you. Yeah.
Yeah, thank you.
Okay, bye. Yeah.
Okay, great. Next presentation, Rats and Company, Thomas.
Hi, Charles.
Hi, Thomas.
Yes, I want to show screen.
That would be great.
Application window. Which one is that? Wait a second. Hackathon presentation. There you are. Okay, can you see it?
Yes. Yeah, it's. I mean, we're seeing. We're not seeing like presentation mode, but you know, it's okay.
Okay. Let me try and see. Okay, so we came here with the Verizon project. The Verizon project is a project we launched 4 or 5 months ago with the goal of building a bunch of open source packages that can be composed into an attestation verification service. And these packages tend to cover several different facets of the attestation verification pipeline. So we have data formats, we have APIs to make agents talk with each other. We have evaluation of the appraisal policy, endorsement and trust anchor configuration, storage, querying, whatever, all that stuff. So this is the second hackathon we do on Verizon. And last time, IETF110, we implemented EAT and Cost Suite from the Rats and SACM working group. And this time around, we wanted to put together a bunch of the components we have built into an instance of the Rats architecture, and specifically the so-called background check model. And we wanted to do that using a specific attestation format, which is the PSA attestation token, and using a specific interaction model, which is a challenge response. And this was one thing we wanted to cover. The other thing we wanted to do was bringing up to speed our EAT implementation with the latest version of the working group draft. And this was very important to us because the latest version contains a new claim that is critical to our workflow, and we wanted to play with it a bit and see if it worked all right. So let's think. So we worked on 4 drafts. 3 working group drafts, and 1 individual draft, which is a draft Shrofenic PSA token, which we want to progress through the independence tree. And what did we do? We did a considerable amount of development and integration in 4 different packages of the Verizon project. Apart from that, we spent a lot of time discussing new ideas about missing tools and stuff like that, or evolution of the API implementation to cover other scenarios. We have PRs that have been merged. We have issues that have been opened, and all that stuff. We have a demo. We put together a demo based on Docker that you could run if you wanted to, and it's there at that URL at the bottom of the page. And we did not do any interop for now, but we chatted with another IT stack to decide the sort of interop test which we wanted to perform, and we agreed with them to schedule an interop test soon, maybe a virtual one instead of waiting for the next cycle. But what we learned is, as I said, we wanted to have this profile claim implemented, and we did it, thanks to Yogesh. And that was very interesting because we realized while doing that the spec as it stands is not 100% correct, and we need to have more precision around interesting bits of it. And so there's a new issue that has been raised, and there's some discussion already ongoing. And I think that this would be will be in fact some kind of feedback that needs to be taken into the discussion next week. To wrap up, yeah, the team members is Yogesh, myself, and Sergey. And Yogesh was a first timer, and I think he enjoyed it very, very much as we did. That's it. Thank you.
Okay. Well, great. Glad you found that issue in the draft now rather than after it publishes RC. That's
Yeah.
great. Exactly what we want to do. So
Correct.
I'll talk to the team for that. Anyone with questions? Okay. Well, thanks, Thomas.
Cheers.
Next up, we have Willem, and presenting on XOT rather than. Oh, sorry, I skipped KJ Sun. Yeah, I see your. And sorry, Willem, we'll come back to you later. KJ, if you can request to share your screen, we'll do that. Okay.
Okay, can you hear me?
Yeah, yes, we can see you too, but not your screen yet. Okay, you should see a request now allowing you to share.
Oh, my screen sharing is not working. So could you pop up my slides chart?
Okay. Yep, let me do that. All right, I'm just looking for the right one here. Why will it not open that? Okay, and BMG, let me find it. Okay, I got it.
Okay, thank you. Okay, now I can see.
Okay, great. Let me
Okay,
just
so
skip.
this is, yeah, so can I start?
Yes, go ahead.
Okay, so this is about the BMWG considerations for benchmarking network performance in the containerized infrastructure. So this is the third hackathon. And then please go to the next slide, please. Yeah, so the main goal of this hackathon is to figure out the container networking performance impact by the various resource options. So based on our draft, so we set up two main features. So the first is implementing containerized infrastructure with the various network models, and second is verifying performance impact depending on the various configuration settings. Next slide, please. Yeah, so the last two, the hackathon, so we set up the environment and then tested some new technologies and then networking models. And then at the time, in this hackathon, our first work is to discuss about the current status of benchmarking in the containerized infrastructure benchmarking area. So the survey and then checking the other works, not only our works. So one of them is the open source activities, which such as the BSPerf in the OPNFV, and another part is the industry, the benchmarking test results, such as the FDIO and then the PDK performance report. So based on that, so we mapping our defined networking model category and the test scenario to map to the other activities, and then based on that, so we want to generalize our test architecture and then the test cases. And the next slide, please. Yeah, and then at the same time, after we check the other activities, and then we are validating the other benchmarking works into our lab environment. So first is using the OBS DPDK and then VPP MEMIF and SRIOV, and then we set up this environment, and then we measure the throughput and the latency and the packet drops in some single port to the external traffic generator. And the other is the multi-post test scenario, which is supported in the VPP MEMIP. And then based on this multiple port-to-port case and then service function chaining case, we follow that scenario and we validating that. And at the same time, we using the other technologies such as OVS DPDK with the same testing scenario. So we are comparing with the existing test result so compare their performances. So these works are still on progress, and then we will get the result soon. Okay, next slide, please. So based on the discussion and then validation, so we need to update our related draft to rearrange our chapters and figures and words, which is more need to be more generalized and then up-to-date technologies, and adding the benchmarking activities. And then for next hackathon, so we are finding remaining area for the benchmarking, containerized benchmarking area. So the first we choose is we choose multi-port in a single host case with the different acceleration techniques. So there is some two part. One part is multiple port to multiple port, and parallelly we send to the packet to the multi-port to multi-port, and then another one is the chaining scenario, which is the traffic should be forwarded sequentially through the multiple ports. And the other the testing scenario case can be the port with multi interfaces. So when the port using the multi interfaces and then going traffic simultaneously through the multi interfaces. So we want to the benchmarking for them, and then want to find some issues which impacts to the performance of the containerized infrastructure. Okay, next slide, please. So here is our team members. So the Professor Young-Han Kim, and then some guys in the IISTRC, the research center, and then Professor Jae-Paul Jung from the Sungkyunkwan University, and then Dr. Hyun-Sik Yang from the KT. So this is our member, and then thank you for listening.
Okay, well, thanks for sharing and for the presentation. Any questions?
Thank you. Thank you.
I don't see anyone in the queue, so thanks again, KJ. And now we'll move to Willem.
Okay, thank you.
And I need to stop sharing. Sorry about that.
No problem. Let me see. Right. Can you hear me?
Yes.
Excellent. Yeah, so these are the results from Project DNS, which turned out to be Project ZOT. So just like previous time, we used this, I used the Mattermost chat server of the DNS Operations and Analysis Research Center, because there are quite a lot of open source DNS developers already there. So it's a convenient and appropriate place to communicate. And it's also open to anyone, so anyone can join and chat about DNS hackathon projects they might have. I have a link on the hackathon wiki as well. But so 1 month ago, I changed the channel name into IETF110 DNS Hackathon, and just when I did that, people started to complain a little bit, right? Because it's a pity that we have to do an online hackathon again, and it would be better to have the in-person hackathon. And with online hackathon, I only have 15 minutes 3 times over the week to spend on this. And I would rather spend a lot more time on it, and because DNS developers actually have to work and are working all week, and so anyway, I decided, well, why don't we organize an in-person hackathon day at the NLNet Labs office? And I proposed that on the channel. And most people were hesitant, but at least one person was enthusiastic about it, which is Matthijs. And so we will have an in-person hackathon day tomorrow at the NLNet Labs office. And I'm looking forward to that one. But besides that, we also did an online hackathon. And so there were quite a few ideas for DNS. People wanted to work on DNS over QUIC, and SVCB came along, catalog zones. But those were all intentions which didn't actually turn out in actual work done, unfortunately, because we have to work. Except for this one, ZOT. So this is what I could find on the Wikipedia, which is like Wikipedia, but then in the Star Wars universe, on Zot. It's apparently a sentient species. But it's also a proposed a draft, an internet draft still. It's actually working group last call has just finished. It's now in AD review state about having the zone, the DNS zone, transferred over TLS. And so there's a lot of things that are involved with that. Like authentication, that you don't, if you really want your zone to be private, you may not leak it in clear text, basically. So there are some things you have to watch out for. And related to Zot, dus the transfer over TLS, is also the extended DNS errors, which is a part of Zot. If you're doing Zot, they assume you're doing extended DNS errors too, but there are actually not that many implementations yet of extended DNS errors, at least not in our software and also not in Bind, I've heard today. So we had to work on that too. Sarah Dickinson set up this excellent hackathon planning document in which everything surrounding Zot was mentioned and all the steps and plans. Unfortunately, Sarah herself got ill this week, so she could not participate. But Shifan, Pallavi, and Han, they were a unit that worked from East Coast United States, I think. They had a mini group in which they talked over Google Meet. At NLNet Labs, we have a new guy named Tom Kapai. He worked on EDE. And all the work from Pallavi, Han, and Shifan was reviewed by Wouter Wijngaards. Peter van Dijk, he worked on Zot for PowerDNS. And Matthijs Mekking, I don't know if he is already working on or will work tomorrow on Zot for Bind. And yes, so part of the planning was also setting up a interoperability testing environment. And for this, I registered the domain name ZotRocks. So I spun up a few virtual machines and gave everybody access to install their software and try out interoperability. Transfer zones over TLS from each other with appropriate authentication. So what got done? Tom Kapai, he made extended DNS errors for NSD, our authoritative name server from NLNet Labs. And this was quite interesting. He found some missing error codes in the RFC. So, for example, a specific error if your DNAME expansion overflows. If you end up with a too large domain name, this is possible. It has a very unspecific response code currently. Pallavi worked on access control lists. Now, if you're doing Zot, you should not do Zot on for the whole of the internet without TSIG, or without TSIG is okay, but then for specific IP ranges. And yes, interoperability testing of Zot. So what did we learn? We still miss the in-person hackathons, but we'll have a mini one tomorrow. Yeah, just me and Matthijs basically, but that's I'm very much looking forward to that. From EDE, maybe we need an update on 8914, or maybe we come up with some more codes that are missing from that. So that's nice. And Zot just rocks. So that's all good. So these are the people that participated. More hacks are coming tomorrow, but maybe next week as well, because the DNS op is on Thursday, and we can still do. We want to do still catalog zones interoperability testing, because I have quite a bit on that draft too. And that's the end of my presentation on the ZOT hackathon results.
Yeah, thanks, Willem. Tom, you're in the queue. Is that for the next presentation, or do you have a question? If you have a question, you can go ahead and share it now. Otherwise, Willem, thanks. You made DNS and privacy and security look like a lot of fun. I'm glad you have all that infrastructure in place. I think that'll help with your in-person hackathon. I'm a bit jealous, I have to say. And I hope that, we don't know about IETF 111 yet. I guess there's still a chance we'll be able to do something in person. So we'll see. We're working on it.
Yeah. Okay.
Okay, great.
Thanks.
And we'll turn it over to Tom. Tom, if you request screen sharing, you should be able to share your presentation.
Okay, can you hear me?
Can hear you, can see you. Don't see your screen share yet. It says it's starting, but then it kind of stops. Oh, maybe looks like you have the ability to share.
Yeah, I'm getting an error. Get display media must be called from a user gesture handler on Safari.
Okay. Is your presentation, have you uploaded it to GitHub?
Yes, I have.
All right, let me go ahead and see if I can find it.
It says I'm sharing now, or it's at least the request has gone through.
Okay, I see you requested, I granted access, so we'll see if we have better luck this time.
No, it says it's shutting down. So if you don't mind sharing.
Yeah, let me find your presentation. Okay. Let's see. What am I looking for here? Oh, the NS3 models. I'm just looking for the name of yours. What's your presentation named? I don't see it.
It's let's see. Should be IETF 110 hackathon presentation NS3. And I had uploaded it about 20 minutes ago.
Let me. Trying to find it. Okay. I don't see anything that's come in the last hour. Maybe it's not in the 110 project.
Just tried it again. Do you see it now?
Let me reload. No, nothing.
All right. Well, why don't I just, in the interest of saving time, why don't I just give a verbal?
Okay, we could do that.
Okay. So yeah, sorry for the technical difficulties. So my name's Tom Henderson, and I'm here representing typically the group that works on NS3 simulation models in the context of the IETF hackathon. And I think we've been doing this for 5 or 6 IETFs now in a row. This time I was pretty lonely. It turned out that many people who usually participates were busy with other things this week. So I basically worked pretty much solo. I had one student stop by, and he was able to help on a starter project, essentially doing some validation of our TCP model. But it was mainly just me hacking this week. The topic that I focused on this week was protocols that are being discussed and under consideration in the transport area working group. In particular, there's a proposal for a new ECN response and protocol. The initiative's called L4S. And I was working to freshen our TCP prog congestion control model, as well as a new AQM structure called the dual queue, which is a draft in the TSV-WG working group. And working on aligning those models both with our latest NS3 development tree code, as well as Linux performance results that were conducted using the Linux kernel implementations of those last year. I also worked to finalize a couple of merge requests for different AQMs. We have, from last year, we had students working on, just as there's FQ-CODL, which is the default QDISC in Linux, there's also an FQ-PI AQM, and we have an NS3 model for that, as well as FQ-Cobalt, which is a component of the overall cake QDISC, which is popular in the buffer bloat community. And so I was able to finalize both of those, and those will probably be pushed to the main line in a couple days. As well as, let's see. So I would share the links. Maybe after the presentation, people who are interested can download the slides. All of our code is uploaded to GitLab. Our finalized proposals have been uploaded to the mainline NS3 GitLab.com instance. And I would share some preliminary results of alignment between our code and Linux results, but I guess that will have to wait, or you could download the presentation at a later time. In terms of what we learned this week, I think it's really, there's nothing that would change any of the existing drafts or RFCs. It was more us getting our models aligned with the latest drafts. But it's really just a capability that we'd like people interested in the working group who may want a simulation model rather than working with Linux code to experiment with these protocols. So it's just a capability to be advertised to the transport area working group for people who wants simulation models of this work. And just to credit, we did have one student, Sachin Nayak, who was his first hackathon, and I worked with him a lot on Wednesday. And otherwise, it was just me working this week.
Okay. Any questions for Tom? All right. Well, Tom, thanks for sharing, and we'll get the where you're. Oh, it looks like is there a question in the chat? Yep. Yari was just telling you good stuff, Tom.
Thanks, Yari.
Yeah, I agree. We'll get it straightened out where your presentation is and make sure it's been uploaded if it's not there already, so that everyone else can find it. And with that, let me see if we have Vlad, because we skipped over Vlad earlier as well, for a Yang model for network tester. know Vlad let me know offline that he was working furiously to get things working, and I imagine that's what he's doing now. So he'll probably have something to share later on. I'll encourage him to just send what he has to the list, send an update to the list, letting people know if he uploads a presentation that they can go and grab it from there. So with that, I think, let me jump back. Looks like I may be getting a problem with screen sharing now too. Request is not allowed by the user agent in this context. Okay, I'm going to try reload. Reloading me, TechGo, and coming back. It seems like I can share now, but sorry, I was gone for a couple minutes there. So I think we got through all the presentations. Is there, Tom, I still see you in the queue, but is that from your previous presentation, or did you have something to add?
Yeah, I did. I'll leave.
Okay. Great. Well, I believe we got through all the presentations. Just a reminder, they should all be here in the 110 project presentations. If any of you have updates, because you continue to work on your project over the course of the next, week or two, or all the way up until the next hackathon, that's fine. You can always update what's here if there's something you think there's useful to share in terms of your results from this hackathon. And I do want to, say a big thank you to ICANN. They've supported us throughout this whole virtual online-only hackathon, and we really appreciate that. And look forward to having them and welcome new sponsors. I don't know if any of you follow, I don't know if it was on the IETF list. There's a new structure for how sponsorship works. They specifically call out things around running code, of which the hackathon is, of course, one. But there's other things too, like the code sprint and other ways to get involved with code. So hopefully that'll help, and we certainly welcome more sponsors, especially when we get back to in-person meetings. Those are a bit more expensive for us to run, so we can have the food and, of course, the beer and cocktails that everyone mentioned. Just want to remind you again, please, for those of you who weren't here at the very beginning of today's closing, we do have a survey for the hackathon, and it'd be great if you could take a few minutes. This is just for the hackathon. I think it's like 10 questions, maybe even fewer, depending on how you answer the first few, and that'll help us. We'd love to have feedback that'll help make future hackathons better, whether they be online or in person. And then also I mentioned the draft that I've put together that covers the hackathon, really from a perspective of how to run it, so that I don't anticipate being a hackathon co-chair forever, and I think Barry has other things that he's probably going to do. So in any case, it's like everything else in the IETF, we like to have drafts that cover what we do. And this one specifically, the reason it came about now and it's in the SHMU working group is because, with the nature of having to meet online because of the current circumstances and other circumstances that may happen in the future, it forced us to rethink a bit about how we run IETF meetings, and certainly the hackathon. And so this isn't specific to running it online. It really covers all facets of the hackathon. And so especially for those of you who just, participated in this one, things are fresh in your mind. It'd be great to get some feedback on that draft from that perspective as well, because I have my view of how it works, but would love for you to point out things, especially things that you think are important and that aren't mentioned in there at all that I need to call out. So that'd be great. It will be discussed in the SHMU working group meeting, which I forget exactly which day that is. I think it's Wednesday or Thursday next week. Would love for you to be in that session, but feedback directly to me or to the working group would be great too. And with that, we're going to wrap it up, and certainly hope to see all of you next time, and hopefully in person as we've discussed. Also, if anyone has any questions, any thoughts, happy to take those now as well. And actually, I have one question for the group. I see some people have already had to drop off, but we had a new template this time that people could use. We've had a PowerPoint version of that template that I know many of you have used in the past. I think Sarah put that together for us initially, and it's been very helpful. And this time Benson, oh yeah, I see Benson's on. He helped put together, or he did put together an HTML version of that template, which we talked about at the kickoff. Just wondering if anyone did use that. If you did, love to hear about how that experience went. And as with everything with the hackathon, we look to make it better next time. So enhancements to the templates, new templates, anything else to make the hackathon better, whether we're in person or like this, would be appreciated. Okay, well, I'll close then by thanking all of you, and hope you have a good weekend, rest up, and hopefully a busy but productive IETF week next week. I look forward to seeing everyone there. And thanks a lot for participating in the hackathon. Really appreciate it. And good luck with the rest of IETF 110.